Hi everyone. So today is going to be our last lecture. So we've just got two more examples to do on finding the length of a curve, and then the lectures will be done. However, on Monday and Tuesday, we're going to have a revision session for test 3. Okay, so I just want to do a little notes on test 3 that's coming up. So test 3. That's next Wednesday. Okay, it's going to be 45 marks. Okay, and you have 1 hour to complete it, and then 30 minutes for submission. Okay, so everyone should have the scope, but I just want to go over that again. So it's going to be on trig integrals, trig substitution, partial fractions, improper integrals, and finding the length of a curve. Yeah. Now, these won't all be separate questions. It's going to be mixed up. So the question on finding the length of a curve, that could require a trig substitution, or the improper integral might be a trig integral, for example. So remember, for improper integrals, that just means the function is discontinuous somewhere, or you have an infinite domain. So that question could involve trig substitution, it could involve a trig integral, and so on. Okay, so it's not like question 1 is on trig integrals, question 2 is on trig substitution. It's just going to be a mix of integrals that you then need to solve based on whichever of these methods you see fit. Okay, so that's going to be the first bit. And then finding the length of a curve, that's going to be a separate question on that. Okay, but again, the integral to find the length of a curve, that might need a trig substitution, for example. Okay, so you do need to know all of your work for that. Okay, and of course, U substitution and all of that, that's covered here as well. Okay, so that's going to be next Wednesday. Okay, and then the Monday and Tuesday, we will have our revision sessions to go over a few more questions. Okay, are there any questions about this test? Okay, let's go through today's problems. So number 1. A curve is parametrized by x of t is equal to e to the minus t cos t, and y of t is equal to e to the minus t sin t. Okay, so we want to find the length of the curve where t goes from 0 to pi over 2. Okay, so we've got a parametrized curve given by x of t and y of t. We want to find the length of the curve where t goes from 0 to pi over 2. Okay, so the first thing we need to find is the x derivative and the derivative of y. So if x is equal to e to the minus t cos t, then dx by dt is going to be minus e to the minus t cos t minus e to the minus t sin t. Okay, so I've just used the product rule over there. Okay, what about y? So y is given by e to the minus t sin t. So dy by dt will be minus e to the minus t sin t plus e to the minus t cos t. Okay, so we've got our two derivatives. Now we need to substitute into our integral. So the length of the curve S is going to be the integral from 0 to pi over 2 square root of dx by dt squared plus dy by dt squared. Okay, integrated with respect to t. So we're going to have the integral from 0 to pi over 2 square root of dx by dt squared. Okay, remember what x was. That's going to be minus e to the minus t cos t minus e to the minus t sin t, all of that squared, plus, and then dy by dt squared. So that's going to be minus e to the minus t sin t plus e to the minus t cos t squared dt. Okay, now we can do a little bit of simplification here. So this is going to be the integral from 0 to pi over 2 square root of, for the first bracket, we can take out a factor of e to the minus t. So it's going to be e to the minus 2t, because we're squaring it. And then inside we can have cos t plus sin t squared. Plus, and then for the next bracket, we can take out a factor of e to the minus t. Remember, it's squared. So we have e to the minus 2t minus sin t plus cos t. Okay, all of that squared. Okay, and again, this e to the minus 2t, we can take it out of the square root now. So this is going to become the integral from 0 to pi over 2 e to the minus t square root of cos t plus sin t squared, plus, then we have minus sin t plus cos t squared dt. Okay, so now we can square this. So we're going to have the integral from 0 to pi over 2 e to the minus t square root of, if we square this, we're going to get cos squared t plus sin squared t plus 2 sin t cos t. Okay, so that's just squaring the first bracket. We can then square the second bracket. So we get plus sin squared t plus cos squared t minus 2 sin t cos t dt. Okay, so now we've got a plus 2 sin t cos t and a minus 2 sin t cos t. Those can cancel. And secondly, we've got a cos squared plus sin squared and a sin squared plus cos squared. In both those cases, those are going to add up to 1. So we're going to have 1 for that and 1 for that. So altogether, the square root becomes the square root of 2. So this becomes root 2, the integral from 0 to pi over 2 of e to the minus t dt. Okay, so it's going to be root 2 minus e to the minus t from 0 to pi over 2. And that's going to be root 2 minus e to the minus pi over 2. And then we're going to have minus and a minus, so that makes a plus. e to the 0, but that's going to be 1. Okay, so we get our total length of the curve. Okay, so this was from t equals 0 to t equals pi over 2. Okay, any questions on this example? Okay, let's take a look at the next one. Okay, so example 2. Okay, so find the length of the curve. Given by y is equal to the natural log of sine x from x equals pi over 4 to x equals 3 pi over 4. Okay, so we want to find the length of this curve. So in this case, we're given the y as a function of x, so we need to find dy by dx. So dy by dx is going to be the derivative of the natural log is 1 over whatever's inside. So it's going to be 1 over sine x. But then by the chain rule, we need to multiply by the derivative of sine x. So we multiply by cos x. Okay, so we end up with cos x over sine x. Okay, or 1 over tan, if you want to think about it like that. Now we need to square this. So dy by dx squared is going to be cos squared x over sine squared x. Okay, so we just square both sides. Now, when we're finding the length, we need the integral. So s is equal to the integral from pi over 4 to 3 pi over 4. And then we have the square root of 1 plus dy by dx squared, dx. Okay, so we've already found dy by dx squared, so we can substitute that. So this will be the integral from pi over 4 to 3 pi over 4, square root of 1 plus, and then we have cos squared x over sine squared x dx. Okay, so we can either write that as cotan, if you know the identity, or we could rewrite the 1 as sine squared over sine squared. So let's do that. So we have the integral from pi over 4 to 3 pi over 4, square root of sine squared x over sine squared x plus cos squared x over sine squared x dx. So I just did that to make the denominators the same. Okay, because if the denominators are the same, then we can just add the two fractions together. So this will be the integral from pi over 4 to 3 pi over 4, square root of, now in the numerator, we get sine squared x plus cos squared x. In the denominator, we just get sine squared x. Okay, now the nice thing about this numerator is that sine squared x plus cos squared x is just 1. Okay, so that means we have 1 over the square root of sine squared x. So this is just going to be the integral from pi over 4 to 3 pi over 4, 1 over sine x dx. Okay, now we haven't really worked with 1 over sine x, but we do know that the reciprocal of sine x, like the reciprocal of cos, this is given by cosec x. Okay, similar to how the reciprocal of cos gives us sec x. Okay, so very similar. So now we have the integral from pi over 4 to 3 pi over 4, and then we have the integral of cosec x dx. Okay. Now this is a standard integral that we should all know. This is going to be the natural log of cosec x minus cotan x from pi over 4 to 3 pi over 4. Okay, so this is very similar to the integral of sec x. Okay, so please remember that one as well. So integral of cosec and the integral of sec, you should know that. Okay, so let's substitute now. So we're going to have the natural log of cosec 3 pi over 4 minus cotan of 3 pi over 4. Okay, that's our first term, minus the natural log of cosec pi over 4 minus cotan pi over 4. Okay, now if the radians, the pi over 4 and the 3 pi over 4 are still bothering you, 3 pi over 4, that's just going to be 270. Pi over 4, that's going to be 45. Okay, so we're going to have, did I say 270? Sorry, that's going to be, so if we just write 3 pi over 4, that's the same thing as pi minus pi over 4. Okay, so you can think of this as 180 minus pi over 4. 180 minus 45. Okay, if you want to think about it in terms of degrees. Sorry, 3 pi over 2, that's 270. Okay, so we have the natural log of cosec of 3 pi over 4. Okay, that's going to be root 2 minus cotan of 3 pi over 4. That's going to be minus 1. Okay, so we end up with a plus 1 minus the natural log cosec of pi over 4. That's going to be root 2. Okay, and then because remember, that's just the reciprocal of sine. Okay, so sine of pi over 4, that's 1 over root 2. Cosec will be the reciprocal, so it's just going to be root 2. Okay, if you want to remember it like that. And then cotan of pi over 4, that's going to be 1. Okay, now you could leave your answer like this, or you could combine the two. Okay, remember your log laws. That's going to be root 2 plus 1 over root 2 minus 1. Okay, but you don't need to do that. Okay, leaving it as two separate logs, that's fine as well. Okay, but if you want to combine them using your log laws, that's fine too. Okay, are there any questions on this example? Okay, so everyone's all right with that. Okay, let's take a look at the homework problem. Okay, so I've got an interesting homework problem for today. Okay, so given y equals 1/4 e to the x plus e to the minus x. Okay, so that's our function. Show that the length of the curve from x equals a to x equals b is equal to the area under the curve from x equals a to x equals b. Okay, in other words, if you measure the length of the curve from a to b, whatever number you get for the length is the same as if you were to find the area from a to b. Okay, so if we just do a little picture of this. Okay, so let's say here's a and b, we've got the curve like that. Then this area underneath is in fact equal to the length. Okay, so the blue area is equal to the green length. Okay, so you need to show that. Okay, and I think this is a very nice test type question as well. Okay, because it involves a few things that you need to do. Okay, so it might come up in your test. Okay, any questions on this homework problem? Okay, are there any specific things that you would like me to go over during the test revision? So for Monday and Tuesday, is there anything important that you want me to go over? Okay, so let's just go back to the sections here for the test. Okay, so anything here that's bothering you still? Okay, so in that case, for the test revision, I'll just find a couple questions to go through. Okay, if you don't have anything specific, I'll just find a few things. Okay, so that's it for Math 196. So all the lectures are done now. If you do have any questions later on, please let me know on the WhatsApp group, or you can email me and then I can help you out. And then over the weekend, please think of anything that you would like me to go over for Monday and Tuesday. Okay, and also please try this homework problem out. Okay, so I might put this on the test. I'll see. Okay. Yeah, but please, if you do have any questions, please let me know. Okay, bye everyone.